This next young man is a veteran of the MT² circuit. He has a master's in philosophy. He has an outstanding French accent. He was doing some teaching and learning in France and in Peru. He has a son that wreaked havoc on our last rehearsal. Ladies and gentlemen, Andrew Wille.
Thank you. And thank you to Michael and to the MFA staff who made this evening possible. It's honestly one of my favorite evenings of the entire year. And it's such an honor and a privilege to be here with you tonight. I want to start with a joke. An infinite number of mathematicians walk into a bar. The first mathematician orders a beer. The second mathematician orders half a beer. The third mathematician orders a quarter of a beer. And the bartender interrupts and says, "Oh, shut up, I've heard this one already." And he pours 2 beers. Now, understanding this joke requires some careful counting. The first beer is not so bad. We understand how the bartender fulfilled this order. He poured a beer. But the question is, how was he able to fulfill an infinite number of orders by simply pouring a second beer? Well, here's one way of thinking about it. Think of the second beer. The second mathematician ordered half of that beer. The third mathematician ordered a quarter of that beer. The next, an eighth, and a 16th, and a 32nd, and so on and so forth. And here we have a really nice argument that those infinite number of beer orders are actually bounded by the second beer, and some of us might even believe that infinite number of beer orders equals exactly the second beer. This joke is brought to us by Archimedes. Now, Archimedes wondered whether or not it was possible to add an infinite number of smaller and smaller and smaller and smaller terms and get a finite result. As far as we know, Archimedes wasn't motivated by beer, however. He was motivated by Zeno's paradox, which asks the same thing. How is it that we can take an infinite number of smaller and smaller things and add to one finite sum? Well, here's one way of thinking about it. If we carefully place line segments of length r, r squared, r cubed, r to the 4th, etc., create a base of a triangle with size 1, create a similar triangle, and slide it into place, we've created a square with side 1. And the red segment on the square has length 1 minus r. And by similarity alone, we have a very nice argument that this infinite sum, the large blue segment, divided by 1, is the same thing as the red segment divided by the smaller red segment. So this infinite sum is actually equal to the ratio of 1 over 1 minus r, all from Zeno. Another formulation of Zeno's paradox goes something like this. Give a tortoise, an incredibly slow animal, any lead, and it's impossible to catch him. Even with our fastest Greek warrior, Achilles, whenever Achilles approaches the point where the tortoise was before, the tortoise has moved on. And when he goes again, the tortoise has evaded him. And again, and again, and again. So the paradox is that even though we think Achilles should be able to overtake the tortoise, it requires an infinite number of smaller and smaller and smaller steps. In the late 19th century, Lewis Carroll wondered if Zeno's paradox applied not only to numbers and not only to physical objects and to ideas like movement, but whether or not it applied to non-physical objects. Specifically, he wondered whether or not there's a Zeno's paradox for logical argument. Let's take a look at his example, which he stole from Euclid. Premise A, 2 things that are equal to the same are equal to each other. Premise B, the 2 sides of this triangle are things that are equal to the same. we should probably draw the conclusion that the two sides of this triangle are equal to each other. And in fact, I do draw that conclusion, and probably most people in this room draw that conclusion. But Lewis Carroll asked, what if you met someone who didn't? Specifically, what if you met someone who didn't believe this logical law, that A and B together, in fact, implied Z? What if you met someone who didn't believe the hypothetical? Well, we might try to convince him. And how would we do this? Well, we could say C. If A and B are true, then Z must be true. Do you accept that? Here's the problem. Even if this person accepts that, they then ask, well, why am I to believe that A, B, and C together imply Z? And if we go down the road of saying, well, because of D, if A, B, and C are true, Z must be true, we immediately fall into an infinite regression. And it becomes clear we're going to need to add E, F, G, H, I, J, and so on and so forth. No matter how many logical steps we add, it seems as if our conclusion keeps evading us. And at this moment, if you feel like you're being swept away, or you're chasing something that you just can't quite catch, well, this wouldn't be the first time that Lewis Carroll has done this to us. The question is, what does it mean? What's the moral of the story? What is it that Lewis Carroll is trying to get us to understand that we didn't understand before? Well, here's one possible moral. All hope is lost. Abandon logical argument. Abandon rational thought. But I don't think this is Lewis Carroll's moral. Because remember the beer. Just because something is infinite doesn't mean we can't learn something from it. So what is Lewis Carroll trying to teach us from this infinite process? Well, a second moral might be this. And I think we are in a remarkably unique and privileged position to understand Lewis Carroll's worry. As mathematicians and scientists, we rely on logical rules. We're comfortable with logical rules, and we understand the importance of logical rules. Yet at the same time, as teachers, we know all too well that there are some people, namely our students, who aren't always convinced by logical arguments. So the second moral might be a pedagogical moral, and it might be this. In our classrooms, there are conclusions that we would like our students to draw. And how often do we give them strictly logical reasons for coming to these conclusions? And if they don't yet believe the conclusions, how tempted are we to give them another logical reason? This will fall into an infinite regress. What Lewis Carroll might be saying is that the things that happen in our classroom, like the questions and the arguments and the explanations, aren't necessarily separate from the justification that leads us to our conclusion. In fact, they might be an integral part of it. Put another way, inference may not itself be inferential. It may be something that is learned, something that we do, and something that we practice. And finally, the third moral of the story might be this. Are logical laws fair and balanced? I think Lewis Carroll might say no. He might say there's not a single set of logical laws that in and of themselves are fair and balanced or are just. And the reason is that if someone asks for an explanation or a justification, we either give them something outside of our logical laws, or we fall into an infinite regress. And this leads us to a shocking conclusion. If there's no set of logical laws that are in themselves fair and balanced, then justice is not blind, because there's no set of laws that can be applied without something else. And so the question becomes, well, how do we decide our logical laws? Who decides our logical laws? And as soon as we ask this question, we get a second question. Who decides who decides? And who decides who decides who decides? And who decides who decides who decides who decides? I'd like to suggest this. What's fair and balanced is not static, and what's fair and balanced is not predetermined. Rather, what's fair and balanced is something that we create. And we create it when we question each other, and we question our thinking, and when we argue with each other, and when we debate one another. We create it in our schools, when we talk about what we're teaching and why we're teaching it. And we create it in our classrooms every day when we engage students mathematically to such a level that they question the very basis of their thinking. Because what I'd like to suggest is that what's fair and balanced is not predetermined. What's fair and balanced is an infinite process. Thank you.